begin by installing the mount that will hold the calibration cell. Next, we will install the calibration cell itself onto the mount. There are 3 holes in the back that we utilize these screws that are provided with the system to mount it to the stand. Next, we will mount the water connections from the water circulation unit. There's an inlet and an outlet for the water to flow from the cooler to the cell. Cables are provided with mating connectors to connect to these connections on the cooling unit. These cables then attach directly to the cell. Check your system that it doesn't leak water once it's turned on. Next, we need to attach the power supply adapter for the control unit. And there are 2 screws provided with this. You can just screw them in by hand. These are the 2 screws. This connects to the side of the box. Push it into place, then secure with 2 screws. Next, connect power to the unit, but do not turn it on. So on the other end of these cables, which come assembled when you receive the system, are these blue 1/4-inch tubing cables with a Swage-lock water fitting. Connect these directly onto the cell. Once they're tight by hand, use a wrench to tighten them all the way. Next, we need to connect the temperature control cable to the side of the box here. So this cable has 2 sides. One says box. This goes to the control box. The other side says cell. This connects here. Push on the connector and secure the screws. Next, we need to make sure we have enough water in our cooling system. For this, only use distilled water. That will prevent buildup in the lines. Use a small funnel and slowly fill the tank. With the unit connected to the calibration cell, turn it on and check that there is enough water in the system. This will pump water throughout the entire system. Fill this until the water level inside the tank reaches just below the top. The last connection we need to make on the cell itself is the gas supply coming into the cell. Just get this tight with your hand and then very lightly with the wrench, and that's good. This will make an airtight connection for the incoming gas flow. So next we need to install the actual sample into the calibration cell. So we have a sample painted with PSP here. One side painted, one side unpainted. And we have a thermal compound here, which we will use to make good thermal contact between the sample and the copper heatsink of the cell itself. Open the cell by loosening these 2 screws. Spread this around. and then add some to the back of the painted coupon. A little bit will go a long way. Place this on the heatsink. And over top, place the retainer. You can then return the front cover back onto the cell and secure with the bolts. Three cables connect to the cell itself. There are two water supply cables and one mixed gas supply cable. On the back of the calibration system, there are connections for the temperature controller, the input and output trigger from the camera, Ethernet connections for communication, oxygen input to the system, nitrogen input to the system, and mixed oxygen and nitrogen out to the calibration cell. Begin by connecting the temperature controller cable with the label box to the calibration box itself. Next, we will connect the mixed gas output to the calibration cell. We made this connection on the top of the calibration cell earlier. Next, we have cables that connect the oxygen and nitrogen supply to the system. This one connects for oxygen. This one nitrogen. This is bottled oxygen, and back here is bottled nitrogen. We have what's called a dual stage regulator on the top. It allows you to set the output pressure and then monitor the bottle pressure inside the bottle. Open the valve. Set these to about 25 psi for the output pressure. No more than that or it will damage the flow controllers. That can be set here. And then open this valve here to let gas flow into the system. Open nitrogen as well. The nitrogen and oxygen lines that connect to the back of the cal cell are connected here on a dual stage regulator. So there's two fittings that are supplied, one on each end of the tubing. These are 1/4 inch, they're called swage lock gas fittings. They're air and water tight. If this is not the connection that you have or need, you can cut this line and put on the appropriate connector. Next, connect the Ethernet connection to the system and connect the other end to a network switch connected to your computer. Next, we will connect the trigger output and input to the system. Connect camera trigger in to the strobe output of the camera. Camera trigger out should be connected to the trigger input of the camera. The last step, connect power to the system. The nitrogen mass flow is set by the program from 0 to 10 standard liters per minute, has a range of 0 to 20 standard liters per minute. And the oxygen is variable based on the set pressure. The range of the flow controller is 0 to 10 standard liters per minute. So when the gas is flowing through the system, when you reach a set point, you will see this number go to 10 standard liters per minute and this number change based on the pressure setting. For the temperature, this is the current temperature of the heatsink in the cell, and this is the set point temperature that is given by the program. now that we have our calibration cell and our calibration box all set up, we can set up our camera and our LED. The camera should be placed normal to the surface of the paint. The LED should be placed at a slight angle different from the camera. This will prevent any direct reflections going back into the camera. On the camera power supply, there are two B and C connections. One is for an output strobe, the other is for input trigger. So as we discussed earlier, we have one line coming from the calibration system box that will trigger the camera and the LED to take an image and pulse when it's on condition. The other one will send a trigger back to the calibration box to let it know that it has acquired the image at that condition so it can move on to the next condition. The LED trigger is connected here via this BNC and it is placed in pulse mode. That means that when the LED receives a TTL input trigger, it will fire based on the input pulse in terms of frequency and pulse width. When the calibration system is turned on, gas will flow into the calibration cell, across the cell, and exhaust out. That gas mixture will determine what the oxygen partial pressure is within the cell, which correlates to a pressure for pressure sensitivity measurements. So this is set at vacuum conditions. So this is the brightest that the paint will be. You should set up your camera with aperture and exposure time at this setting because it will not get any brighter.